So, hello everyone. Today, basically, we are going to discuss uh, from the point where we have stopped into our last lecture. So, in our last lecture, we have seen our acidity and basicity concepts. So, among the acidity and basicity, generally, we have seen that Arrhenius acid-base principle. So Arrhenius acid is an acid which upon dissociation can release H plus ion. Another substance, basically base. So according to Arrhenius principle, that acid is a substance which can donate OH minus ion. Right. So this is called Arrhenius acid-base theory. Then after this Arrhenius acid-base theory, one more theory we have learned, that is Laurie-Bronsted acid-base theory. So there were certain limitations of Arrhenius acid-base theory. So this theory, which were exactly um, I mean to say, which was proposed by two different scientists, Laurie and Bronsted. So according to these two people, Laurie Bronsted acid is a substance which will release H plus ion. Okay, so and this Laurie Bronsted base is a substance which is going to accept this. The substance which will donate the H plus ion is called acid, and the substance which will receive, which is going to accept this H plus ion, is called as Laurie Bronsted base. So under this phenomena, we have revised certain terminologies. We have learned certain terminologies. What is called acidity and basicity. So let me just give you some brief about this. Acidity and basicity are the relative phenomena which depends, where acidity depends upon the stability of conjugate base, and basicity depends upon the stability of conjugate acid. So these are some of the concepts which we have seen in our last class, and then we have summarized that certain substances are there, that they can be also classified depending upon the relative acidic character, whether they acid or are they base. Okay, so uh, pH is one of the parameter which will able to claim the acidity or basicity of a reaction medium. But the pH of a particular substance is not that much important as that of the pKa, which is negative logarithm of ionization constant weak acid, that is Ka, और उसका नेगेटिव लॉगरिथम लेते हैं तब बनता है pKa. Okay, so pK is more definite parameter which can help us to determine the stability, or which can help us to determine the acidic character. And so vice versa to this, if you want to determine the basic character, then we can take the help of pKb. Okay, so friends, now we have to discuss for. Yeah, so in this basically we have to refer this what is called Lewis acid character and what is called Lewis base character. So previously, whatever the concepts which were given by Laurie Bronsted and Arrhenius, they defined that why, let us say, ammonia is a is a basic substance, and why this trifluoroboron or BF3, why that boron trifluoride is acidic substance. So Lewis was G.N. Lewis, basically the person who gave the concept of covalent bond. So he has given this theory, and according to him, Lewis acid is a substance which is going to accept the lone pair of electron. So lone pair means two electrons which are with each other, then it is called as lone pair of electron. Okay, so these two lone pairs, if they are together, then they are, if the substance is accepting the lone pair, so it is called as Lewis acid. उसके बाद भी और एक सब्सटेंस है जिसको बोला जाता है लुइस बेस. So Lewis base is a substance which are going to donate the lone pair of electrons. So that's why they are donating, hence they are called as a base. And if they are accepting the lone pairs, then they are termed as acid. And acid means Lewis acid and Lewis base. So I'm giving to uh, going to show you one basically examples with the help of this whiteboard, Jamboard, so that I shall show it to you that how this is can be applicable to see how the way Lewis acidic substance or this kind of substances basically can play the role. Okay, so let me present that screen in front of you so that you people can see it. Yes. So I was discussing about this BF3, basically one kind of BF3 and ammonia. So boron is the one of the element. If it is attached with three of the nitrogen, then it will constitute the atom. So which we used to call it as generally boron trifluoride. So boron trifluoride is the element BF3. I am drawing the structure here. Yeah. So the specific characteristics of boron trifluoride is that boron is an element having five electrons, basic total, but outermost orbital will have total three electrons. So in this context, there will be some its vacant p orbital are will be there with boron. Okay, so what the task is done by ammonia, that ammonia is a basic substance, and similarly that is also connected with three of the hydrogen, likewise this. So NH, I am just drawing the structure like this because I have to show some connectivity between this boron and ammonia. Okay, so here ammonia is having a lone pair. So I'm showing that lone pair with the help of certain dots over here. Okay, so yeah. तो बेसिकली नाइट्रोजन के पास तो एक लॉन पेयर होता है और वाटर है ऑक्सीजन का सो इट विल हैव टू लॉन पेयर्स एंड बोथ ऑफ दिस लॉन पेयर्स व्हिच विल हैव डिफरेंट डिफरेंट काइंड्स ऑफ configuration. Okay, so now let me show that lone pair to you. Now if the reaction between occur for this of the these two substances, then it will make one complex between each other. So here the complex will occur in such a way that whatever the boron which is present over here, so it shall try to give the coordinator structure with the fluorine. Uh, Likewise, here is a fluorine, one more fluorine. ठीक है, ये boron है, boron trifluoride, and it will make a complex with itself. This one, yes. Here, nitrogen will be there. This nitrogen is further will be making a complex with hydrogen. Okay, and there are three hydrogens are there which are connected with this. They are here. Okay, then we can have this. Fine. So ये इसके बीच में होगा whatever the lone pair which is there. So nitro that will start from a nitrogen of ammonia, and they will remain directed towards this boron trifluoride का जो boron है ना. So if they shall try to donate the lone pair from nitrogen to boron, in this way they will be directing, I mean to say, lone pairs. So here, for example, boron is accepting the lone pair. That's why it is called as more clearly uh, Lewis acid. Okay, so Lewis acid is this boron trifluoride, and this ammonia is having a lone pair, so it is donating. So that is basically called as Lewis and base. Okay, so accepting substance is called as Lewis acid, but donating substance is generally called as Lewis base. And here we have basically this complex, likewise this, and here the complex is that is called Lewis acid base complex. And so this complex is generally termed as Lewis acid base complex. Yeah. So this is about that Lewis acid base theory. So this is the most recent popular theory that people are following this context, and this is most widely used as well because uh, इसके बाद most of the substances we can classify based upon the lone pair availability, whether it is Lewis acid or whether it is Lewis base. Okay, so that was the acidity and basic characteristics which I wish to discuss and share with you. Fine. So then after this one, we have learned several of the isomers and also have studied a lot more than about their configurations. So simply we need to learn their classification, what are their basic examples, etc. So that we have already revised in our discussion. Then we have also seen that what are called the stereoisomer, these constitutional isomers. So the isomers, so let us start in the depth of this isomerism and concept. So what is called isomerism? The occurrence of isomers is called as isomerism. So isomers are the substances which are having similar molecular formula, but they are having different structure with respect to the arrangement of atoms, with respect to the connection of the atoms. So they are called as isomers. Two types of isomers are known. One of them is called as constitutional isomer, another isomer is called as this stereoisomers. So constitutional isomers are the isomers they are called as functional group isomers, because only the difference is that these are the isomers which are having their functional group is different, so that's why they are termed as functional group isomers, or it is also called as functional group isomerism. And these examples can be, let us say, alcohol and ether, so they are functional group isomers. For example, ethanol and dimethyl ether. Sometimes we can have other kinds of functional group isomers such as cyanide and isocyanide, or nitrile and isonitrile, or also we can call um, aldehyde and ketones. So they are also functional group isomers. Fine. Then after this, and one more isomer that is called as stereoisomers, जिसको हमने अभी तक study नहीं किया है, but stereoisomers are the isomers which can be classified depending upon their 3D structures of the arrangement of the atoms in 3D structure. Fine. So these 3D isomers, structural isomers, which differ from each other in 3 dimensions. So last time we have seen whether it is a x-axis or y-axis, or x-axis, y-axis, or z-axis. So that we have seen in our last session, where this several classification of the isomers is there. बट आपके सिलेबस में उतना डेप्थ में नहीं है, बट व्हाट फिर भी व्हाट आई शैल डू, आई शैल ट्राई टू डिस्कस विथ यू पीपल रिगार्डिंग वन और टू lectures with you, so that you can be aware about what can be the functional group isomers and so on, the stereoisomers as well. Okay, so before we start the stereoisomers, तो उसमें भी हमने classification किया था which are optically active, which are optically inactive. तो आप स्टीरियो केमिस्ट्री पढ़ के आए हो, ऑप्टिकल आइसोमरिज्म पढ़ के आए हो, तो आपने ऑलरेडी पढ़ा होगा कि देयर इज समथिंग कॉल्ड पोलराइज एंड नॉन पोलराइज लाइट. ठीक है. जनरली द लाइट which is coming from the sun, that is consisted of so many kinds of radiations. आपको जब when you will be in your third year PharmD, you will learn that there are so many types of the radiations: X-rays, UV, IR, visible light, microwaves, infrared, etc., etc. And nuclear magnetic resonance करके भी there are certain radiations, and each and every radiations have their certain wavelength. Some of the radiations are hazardous to us, such as UV light, which are coming from the sun, but because of the O3 ozone layer, we, the people, are safe on the earth. There are certain ozone depletions on certain parts of ozone layer, and because of this UV radiations are reaching to the earth, and it can cause damage to us, such as skin cancer, etc., etc. Okay, so now what are these radiations? So each and every light, normal light, visible light, is having so many oscillation in itself. Oscillations means more than one plane. So particular light is composed of so many planes of each other, but these planes, if it is passed through a particular substance named as polarizer, then this will the polarizer will allow to pass the only plane which is exactly perpendicular to itself. ठीक है, ये फिजिक्स में थोड़ा पढ़ा होगा आपने. So polarizer are these kinds of substance. Sometimes they are made up of tourmaline or calcium carbonate, etc. And उसकी जो एक्सिस होती है पोलराइजर की, उसकी एक्सिस के साथ पैरेलल होने वाले रेडिएशन ही उससे पास हो सकते हैं, और उसकी एक्सिस से जो मैच नहीं होते वो पास नहीं हो सकते. तो जो लाइट वो पोलराइजर से पास होगी उसको बोलते हैं दिस polarized light, because it is having the oscillations in only one plane. Non-polarized light is having oscillations in all the possible several planes. Simply I can show it to you that but with the help of this tool. uh, Likewise, polarized light is having the oscillations in only so more than one planes. Maybe we can consider each and every planes like this. Okay, so I'm trying to draw all the kinds of oscillations where the oscillations can be possible. Basically, I'm trying to draw the arrows of all of these oscillations, so you can be aware about this. No, I mean to say non-polarized light. So consider all of these oscillations which is possible for non-polarized light. Although my diagram is not that much clear, but with this diagram, I wish to make you people aware about the this oscillations of the plane polarized light. Okay, so considering this as a non-polarized light, so this is basically non-polarized light, and we wish to transfer, basically wish to convert, if we pass this non-polarized light, let us say through certain substance which is a polarizer. So polarizer which will be somehow material like this. So we will be passing this plane polarized light into this direction here. So what will happen, for example, if it is having oscillations into this plane only, this is nothing but our polarizer. So polarizer is like this. तो उसका एक axis है, likewise there is a axis means which can divide the substance into two equal parts. तो उसका जो axis है मानो कि vertical है 90 डिग्री है. तो what will happen after once this polarized non-polarized light, if it is passed through this polarizer, then after passing this light will have oscillations only in this directions. Okay. तो बाकी के ऑसिलेशंस कहाँ गए जो टेढ़े मेढ़े और उल्टे सीधे थे, ये सारे ऑसिलेशंस कहाँ गए? वेयर इज दिस वन, वेयर इज दिस वन? So we can say that they could not pass out from polarizer and they are absorbed from this polarizer, and this light is now called as polarized light. Okay. So this light is now polarized light because it has passed through the polarizer, और polarizer की जो particular उस ये था एक्सिस थी उसी को ही वो क्रॉस कर चुके हैं. Fine. So now our next agenda is that if we pass this polarized light through a certain substance, which is, let us say, some particular, let me draw certain this thing, and if we have a copy of another particular, basically I'm trying to draw a particular tube. So this is a tube which is filled with our sample. So we have filled our sample into this one, which is basically liquid. And if this liquid is there, then we are adding a particular solvent into that to prepare our sample, to prepare our this material which is filled with the liquid. So I'm trying to draw that liquid here as well, so that you can have idea that this is a uh, sample tube which is filled with the sample of our interest. So if it is, let us say, uh, substance is there, solid is there, then we will dissolve it into a liquid, will make the sample, and that sample we will fill into this sample tube. ओके, सो सैंपल ट्यूब से जैसे ही वो बाहर आएगा ना, तो आपका जो plane of, if the polarized light is will have oscillations in some other direction. So let us say in this direction now, these oscillations is there. So once it has come out through certain flow. So previously it was actually having in the oscillations, let us say in this direction here. Fine. So here it was having this oscillations in this direction previously, but actually before passing through a particular polarizer, it was having the oscillations in this direction here. So here it was that. Now after it is having the oscillations in this direction, I mean to say this one. So why it is so? पहले तो ऐसा था, फिर थोड़ा टेढ़ा हो गया. So why it is so like this? That is because of the presence of, I mean to say, the substance which we have filled into the sample tube. So इसीलिए here actually a certain kind of angle is there which we observe, and this angle is basically called as, if I write clearly here, it is called as theta. Okay, so that's why we need to be very we need to understand that if then this is basically complete a property of whatever the sample we have filled into the sample tube here. So this is one of the diagram which is basically a kind of instrument which is called as polarizer, or we can also call sometimes or we can maybe, since we can measure, it is called optical rotation. So this angle theta whatever we have measured, so that is called as optical rotation. And the instrument is we used to measure for this, that is used to measure this optical rotation. Okay, so uh, this is basically called optically, if the substance can rotate the plane of polarized light, it is called as optically active substance, and the substance which can not rotate the plane of polarized light, it is called as optically inactive. So that depends upon the this way, that whether it is optically active or optically inactive. Okay, optically active means substance which can rotate the plane of polarized light is called as optically active. And the substance which cannot rotate, ये जो substance था इस temple tube में था, उसने ये plane of polarized light को थोड़ा सा हल्का सा rotate कर दिया, इसलिए it is called as optically active because it has rotated the plane of polarized light. But if it cannot rotate or plane of polarized light जैसा था वैसा ही equal बाहर आता है, so it is called as optically inactive substance. This way, we can understand the concept that what is called optically active, what is called optically inactive. So, optically active isomers are, we can further divide them into optically active and optically inactive. That is for configurational isomers. So, configurational isomers are having optically activity and optical inactivity. कॉन्फ़िगरेशनल आइसोमर में ऑप्टिकली एक्टिव में हमने देखा है बहुत सारे कैपिटल आर कैपिटल एस और डेक्स्ट्रो लीवो रेसनिंग मिक्सचर so this we capital L capital D, so we shall refer these points one by one. As well as optically inactive में भी हमने देखा है isomers which are called cis isomers, trans isomer, capital E, capital Z. So basically they are optically inactive configurational stereoisomers, and उसमें भी types are there, cis, trans, E and Z, so that we will see in our sessions also. So these are configurational isomers. और उसमें भी दूसरा जो types है under the stereoisomers. So stereoisomers are generally classified into two types. What is called this configurational isomers and conformational isomers. So let me clear this frame so I can give you some introduction to you people regarding one more terminology that is called conformational isomers. Yeah, so friends, this conformational isomers is a kind of isomers which differ from each other through a carbon-carbon single bond. So if the isomers are having a carbon-carbon single bond like this, and they are having certain different conformers, they are having different rotations. So likewise, this is also one conformer where this my one you can consider this as one of the atom, this as another atom. So both the atoms are exactly opposite to each other. So angle between them is 180 degree. Okay, but so in here is a carbon-carbon single bond. So they are termed as either we can maybe normally we can study this kind of conformations which differ from each other. The isomers which are having carbon-carbon single bond but differ from each other through the rotation across a carbon-carbon single bond. Let us say if likewise if one carbon is likewise this, other carbon is also here, so rotation can be possible in between these two carbons across the axis or across the bond, and that's why they can show the different isomers. But one thing we need to be much clear that this conformation, the word which we are using is completely different from conformation. Okay, so conformation is means to decide, to fix. So there is a lot of difference between your conformational isomers and this is conformation, because this conformation, the dictionary meaning of this conformation, that is one kind of adjective of the verb what is called to conform. To confirm means to decide, to fix, and to make to decide, to make, fix, and to reach to particular conclusion. So that is called confirmation or confirm, to confirm. That is completely different from whatever we shall be learning from this confirmation. Okay, so these are the conformational isomers which are generally for a kind of carbon-carbon single bond containing compounds, and among the carbon-carbon single bond containing compounds, this is majorly for, let us say, I mean to say this your mm, alkanes, and alkanes maybe there are several types: ethane, propane, butane. So उसमें भी you people have already educated yourself during several conformations can be possible. इथेन में भी पॉसिबल्स है विच इज कॉल्ड, आप दो कार्बन बॉन्ड एक दूसरे को अटैच करते जाओ तो लेट अस से इफ द बोथ द हाइड्रोजन्स आर likewise in this direction, it is called fully eclipse. Because if you observe this two carbon, so if I say that let's say this is one carbon, this is other carbon connected with each other through a carbon carbon single bond, तो आप जैसे इस ओरिएंटेशन में देखते हो तो you can see both the carbons, but if you visualize from this, then you will be only able to observe the top carbon, the front carbon, but the rear carbon shall not be visible to you. So that way, the front carbon is there. This is a another carbon. So there are several confirm kind of geometrical structures are available. The trajectories are available, which is called to represent a 3D molecule in two dimension. तो उसको बोला है projection. So Sohor's projection, Newman projection are a particular kind of this conformations with the help of which we can study the conformational isomerism. Okay, and there are this conformational isomerism is basically possible through the several types of the projections. So let me show that projection to you people so I can educate you from, although certain book is with me from where I am showing this stereoisomeric conformational structures to you people so that I can educate you regarding what is called the projections. Okay, so there are several types of the projections are available, and these projections are more important to represent any chemical molecule which exists in three dimension on two dimensional piece of paper like this. So on a piece of paper we can present any molecule. Just say if somebody is asked to draw your picture into a or canvas paper, likewise, so the painter will draw your picture on onto the 2D paper. ठीक ही उसी प्रकार जैसे ह्यूमन का पिक्चर 2D पेपर में आ सकता है, तो सिमिलरली मॉलिक्यूल का भी पिक्चर 2D में प्रेजेंट कर सकते हैं, बट उसके लिए सिंस इट इज केमिकल मॉलिक्यूल तो देयर आर सर्टेन रूल्स, और ये जो रूल है ना उसको वी कैन एज्यूम, वी कैन कैटेगराइज विद द हेल्प ऑफ दिस formulas, what is called perspective formula. तो ह्यूमन का पिक्चर पेपर में ड्रॉ कर सकते हैं, तो मॉलिक्यूल का पिक्चर भी पेपर में ड्रॉ किया जा सकता है with the help of perspective formulas, Sohor's projection and Newman projection. Okay, so what are these perspective formulas? So we know that carbon is basically tetravalent carbon, tetrahedral carbon having 108.5 angstrom. कार्बन में भी बहुत सारे टाइप के बॉन्ड होते हैं, द बॉन्ड विच एक्सिस्ट विद इन द प्लेन, द बॉन्ड विच इज कमिंग आउट ऑफ द प्लेन, द बॉन्ड विच इज गोइंग बिहाइंड द प्लेन. So there are three types of the bonds. Okay, so consider your screen of your whatever you are observing either in your mobile or in your laptop as one plane. So plane में जो bond है ना उसको highlight करते हैं single line से. तो ये जो line यहाँ पे दिखाया गया है, let me highlight, yeah. So as you can see, I have selected a line between two carbon carbon, so that is a bond which exists within the plane of your mobile, within the plane of your laptop. Okay, so the bonds which exist within the plane, they are represented as a single line. The bonds which are coming out of the plane, so let me select that bond for you. If this allowed to me, only I will be able to select the hydrogen, because वो bond मुझे select नहीं करने देगा. तो ये दोनों हाइड्रोजन और कार्बन के बीच में जो बॉन्ड है ना, जो विच इज अ सॉलिड बॉन्ड. So solid bond, that means which is coming out of the screen of your mobile, out of the screen of your laptop. ओके, ये जो कार्बन और हाइड्रोजन के बीच में एक स्ट्रॉन्ग बॉन्ड, एक सॉलिड बॉन्ड ड्रॉ किया है, जिसको वेज टाइप है. वेज टाइप मीन्स आपकी जो घरे તમે ખીલ્લી જોઈએ છે ને, તો ખીલ્લી જેવો બોન્ડ છે કે એનો એક બોન્ડ એક એન્ડ છે that is very sharp and other is very flat. ઓકે, સો એવું કેમ છે શાર્પ અને ફ્લેટ? તો શાર્પ અને ફ્લેટ નો મિનિંગ એવો થાય કે તમે કાર્બન થી હાઇડ્રોજન તરફ જાઓ તો એ જે ધીરે 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 ડિસ્ટન્સ વધી રહ્યું છે. The distance is slowly increasing as you move from carbon to hydrogen. Distance is slowly increasing as we move from carbon to hydrogen. So to represent this, the bond is shown as a solid bond. Okay, so I hope that this is clear to you. Whenever a particular bond which is coming out of the plane, so that way it is represented always as a solid bond which is coming out of the plane like this. Consider this as a plane, and if you want to show something coming out, so it will be like this. But to represent in 2D paper, it is represented as a solid. Okay, the bonds which exist within a plane, so they are like this and drawn with the help of line which is coming out of the plane. They are drawn with the help of solid bond, and which are going behind the plane. So that bonds are represented with the help of this dash wedge. So आप जो ये वेज डैश बॉन्ड दिख रहे हो ना कि डॉटेड लाइंस, लेट मी सिलेक्ट द हाइड्रोजन एंड दिस कार्बन. सो ये हाइड्रोजन और कार्बन के बीच में जो बॉन्ड है उसको बोलते हैं वेज टाइप ऑफ बॉन्ड. बट दिस वेज, WEDGE, is a kind of broken wedge. वो टूटा हुआ है. It is a dash wedge. So that is not a fully filled, that is a dash lines. So dash line indicates a particular bond which is going behind the plane. जो पीछे के प्लेन में जा रहा है, प्लेन से पीछे जा रहा है. तो प्लेन मीन्स समतल, प्लेन मीन्स योर प्लेटफॉर्म where you can see this concept. Okay, so these are major three kinds of structural features to represent a tetravalent carbon. Solid line indicates the bond is within the plane. Sorry, the simple line indicates bond within the plane. This solid bond that indicates a particular bond which is coming out of the plane. A dash wedge which is indicating bond which is going behind the plane. Okay. तो ये जो फॉर्मूला है ना उसको बोलते हैं पर्सपेक्टिव फॉर्मूला. पर्सपेक्टिव फॉर्मूला का मीनिंग यही होता है हाउ डू यू परसीव, हाउ डू यू परस्पेक्ट, हाउ डू यू, व्हाट डू यू अंडरस्टैंड from this structural concepts. So that way it is termed as perspective formula. Formula means just to represent something. So this formula is called as perspective formula. Another formula is called as Sohor's projection because it was given by the scientist name as Sohor's. So Sohor's के नाम से ही this projection is called as Sohor's projection. दिस प्रोजेक्शन, जैसे मैं आपको दो कार्बन कार्बन सिंगल बॉन्ड दिखाता हूं तो इस हिसाब से आप दोनों कार्बन को, एक कार्बन नंबर 1, कार्बन नंबर 2 एंड कनेक्टेड विथ ईच अदर थ्रू अ सिंगल बॉन्ड दैट यू कैन ऑब्जर्व. बट इफ आई मूव लाइक दिस तो आपको एक ही कार्बन दिखेगा, पीछे वाला कार्बन आपको नहीं दिखेगा. दिस कार्बन इज कॉल्ड एज फ्रंट कार्बन एंड दिस कार्बन इज कॉल्ड एज रियर कार्बन. जैसे बाइक में दो पहिए होते हैं, एक फ्रंट व्हील बोलते हैं, दूसरे को रेयर व्हील बोलते हैं. सो बोथ ऑफ दिस इज कॉल्ड आइदर एज फ्रंट व्हील और रेयर व्हील. तो सिमिलरली ये जो सोहर्स प्रोजेक्शन है उसमें हमें दो टाइप के कार्बन मिलेंगे. द फ्रंट कार्बन विच इज इन फ्रंट ऑफ यू एंड द रियर कार्बन विच इज एट द बैक साइड. ठीक है. सो दिस वे सोहर्स प्रोजेक्शन इज जनरली टर्म एज दिस काइंड ऑफ projections. Okay. Then another kind of projection is called as Newman projection. So this projection, which was given by the name of the scientist called as Newman, and from his name, these projections are called as Newman projection. तो न्यूमैन प्रोजेक्शन में क्या होता है? दिस न्यूमैन प्रोजेक्शन, एज यू कैन सी, इट इज लाइक अ सर्कल एंड हैविंग सर्टेन periphery from its side. So that is why it is called as a Newman projection. So let me show it you again with the help of this Jamboard so that I can make you aware about what is called this Newman projection. So friends, this Newman projections is generally drawn with the help of a particular circle. Likewise this. ओके तो सर्कल में जो एक सेंटर होता है राइट यू नो दैट ईच एंड सर्कल विल हैव अ सेंटर सो द फ्रंट कार्बन विच इज विथ अस सो दैट इज ऑलवेज उसके जो बॉन्ड्स है ना दैट विल ऑलवेज स्टार्ट फ्रॉम द सेंटर और जो रियर कार्बन है उसको सबसे बड़ा गोला सर्कल करके रिप्रेजेंट किया गया है so your the center of this circle is your front carbon and the periphery of this circle periphery means outermost portion so outermost portion of this is called as this rear carbon तो फ्रंट कार्बन से तो आपके फ्रंट कार्बन ऐसे में रखता हूं तो उसके बॉन्ड आपको विजिबल है इसीलिए उसके जो बॉन्ड्स हैं दे आर always shown from the center of the circle likewise this okay so the carbon which is attached with three hydrogens so you can assume that there are three hydrogens which are here connected with each other so these are the three hydrogens और एक attachment है वो carbon के साथ है and this carbon is at the back position so front carbon के जो attachments है वो center of the circle से start होते हैं और जो back carbon के जो attachments है they will start from the periphery of the circle okay so here this further three hydrogens will be attached so this kind of projection I have drawn for ethane and that is basically called as Newman projection because there was one scientist whose name is Newman and from his this projection is called as Newman projection. Okay, I hope that this concept of Newman projection, perspective formula, and Sohor's projection may be clear to you. So Newman projection will look like this, which is having a particular circle and a periphery. So circle के जो carbon है, they shall start from the front carbon के जो attachments है, will start from the center of the circle, and the rear carbon which will start उसके जो attachments हैं, they will be irradiating from the periphery of the circle. This Sohor's projection is also called as endiron formula because or sometimes it is also called as wire formula because Sohor's projection के जो attachments है they are having a kind of wire formula or a kind of endiron formula. Okay, so this is about Sohor's projection and this is about Newman projection. So out of these three projections, Newman projection is one of the best conformation which can help you to study the conformational analysis of your compounds. Likewise this. So this is the way that several conformations of your compound you can study and that you can generate with the help of these structures. And for example, let us say butane. So considering the have both the then let us say this is 60 degree 0 degree rotation then further 60-degree rotation to this carbon carbon single bond which will convert a Gauss conformation likewise this conformation B is your Gauss conformation C is your partially eclipse conformer because you have rotated the structure at further 60 degree your is anti के बाद फिर आपका ये each and every 60-degree rotation which will give another isomer likewise this okay so 60-degree rotation to this fully eclipse conformer will end up in a Gauss उसके बाद और 60 degree so we will end up in partially eclipse conformer C then we will have further 60-degree rotation then this anti conformer then the further 60 degree it will give another partially eclipse conformer and 60-degree rotation to this we will have and we will end up in our original conformer A. Okay, so there are several conformers Gauss, NT, and partially eclipse, fully eclipse. So out of this, all of these conformers, NT is more stable than the Gauss, and even that is more stable than partially eclipsed and fully eclipsed. Okay, because of the 180 degree, this in this conformer 180-degree bond is there, and there is steric hindrance will be less, and there will be less clashes in between these two methyls. This is simply like that. There are two brothers, but one brother is in America, other brother is India. So there will be no fighting in between these two brothers. But if they are present in a one common room or one common family, then there will be fighting between these two of the brothers for whatever their needs. Okay, so similarly for anti-conformer, both the methyl groups which are present over here, and since that way both are stable, but moment they become close to each other having 0-degree rotation likewise this, then they will have a lot of spherical clashes among them, and that will cause the least stability of this fully eclipsed conformer. Okay, so whatever things I have got taught you people, that is already available in organic chemistry by Bruce, and you can visit the same. So let us stop our session for up to this one. In coming lectures we shall be discussing the stereochemistry of cyclic compounds from this onwards. Okay, so with this let us stop up to here. Thank you everyone, thank you so much.